This video I'm going to be going over the door bars, so the first thing of course is to go over the rules and different designs. In drifting, door bars are a big deal because drifting has a lot of side impacts involved with it. Because our cars are traveling sideways, we tend to hit walls or hit barriers sideways, or also get plowed into the side from other cars. So a big deal with building the door bars is to build them to try and protect the driver the most and protect our hips and protect our legs from that side impact. Okay, so I'm going to cover a few different designs of door bars. This in no way covers all the different designs of door bars because there's just so many out there. But I'm just going to cover like the 2 to 3 most common choices. First rule of thumb is that it should minimum cover the halfway height of the door. That's kind of like the good rule of thumb to go by. So over here, this is the halfway height of the door. And then up front, that's measured to be the halfway height of the door. You can always go higher, of course, but you have to make sure to take into consideration getting in and out of the car. And on the bottom here, I've gone as low as I possibly can, with still giving me room to weld all the way around the bottom of the roll cage. So in FD, they cover 2 main door bar designs. So the first one is a door bar design where both the bars intersect each other in an X formation, such as this. So just in reference for this video, I'm going to call that the X bar design, and I'm going to go over that right now. So in your X bar design, one of these bars is going to be solid, and the other one is going to be split in half and then notched and then welded in the center, and that continues off to continue to the rest of the cage. One thing that I want to cover about the X bar design is that, as you can see on the bottom here, it leaves quite a bit of open space on the bottom, and just because the way the X forms, it tends to go down a little bit further in the center. So in the center over here, you generally have a lot less protection than you normally would going with like the parallel bar design, which is the second design that FD goes over. In my opinion, it's kind of a big deal in drifting because drifting, you're really worried about your side impact over here, and you're really just trying to protect your legs and your hip and all that sort of stuff from incoming wheels that are going to come in and smash into your door during tandem. So me personally, if I was doing an X bar design, I also run a bottom bar like this, which is considered a sill bar according to like NASA spec. And NASA actually makes that a requirement when you're doing an X bar design, that you also run a sill bar going along the bottom portion of it. So that way you still have your X over here, and you got one going along the bottom, so you have this entire area covered. And I'm going to show you why that's such a big issue when you go up to do a bigger X design that covers the entire bar, which I've seen people do. Now, as you can see, when you take that X bar design and you make it cover the entire area of the door, you have a ton of open space over here. So this to me is like a big red flag, just because I'm thinking, in tandem, your main thing is someone's going to be plowing into you. And if you notice, this seat is actually sitting as far back as it can go right now with the cage in there. If you actually sit this seat up, your hip area is like right over here, which is right where this empty space is. So if I'm thinking about, if I'm going to smash into a K-rail or, have another car plow into me, all that impact, there's going to be no protection over here protecting my hip area and my leg area, which is why in that case, I'd want to make sure I have this lower sill bar going across, because if I have this lower sill bar here and I have my X bar up top, I basically have this entire area covered and it's not going to touch my hip. So that covers the X bar design. Basically have one continuous, one cut in half. Try run a lower sill bar if you can, because it's going to give you the most protection in a side impact, which is what you're looking for when you're building your door bars. Okay, so the next door bar design is a parallel bar design. So the way that FD describes it is there's basically one lower bar, one parallel upper bar, and then you need to have a minimum of 2 intersecting pieces such as these in between them. Now, when they mean by parallel, they don't mean exactly parallel. It's basically just you need to have one lower bar and one upper bar. So as you can see, this one has a slight bend here. That's perfectly fine. And then, of course, you have your 2 intersecting points. So this right here is what I prefer doing over the X, which is why I've done it. Because as you can tell, it covers basically all the way to the bottom. It covers all the way up top. So it gives you more protection on the lower end compared to the X. It also gives you more protection on the upper end compared to the X. And as you can tell, this entire area is basically blocked off with a door bar. So I'm looking at that, and I really like that because of the side impact protection that it has, which is a big deal in drifting. Now, there's a whole bunch of different variations you can do with this. So there's a lot of different people that'll do different gussets over here. They'll mount more intersecting pieces. They'll make this come down diagonally. They'll make it go back like that. So whatever you do, just try and keep in mind to protect against the hips, because I've seen some of these bars where they don't start them up until about here, and then they continue them up until here, which then I'm looking at the door bar design, and basically the entire area of the driver's hip and lower is completely exposed from the side. So my whole idea with this is to try and go down as low as you can, and to basically try and go up as high to keep yourself protected. The last design that I'm going to go over is the NASCAR style door bar design, which that's basically like a parallel door bar design, except that the bars bend outward and into the door itself to give you basically the most side protection that you can possibly get, because it positions the roll cage as far as possible from the driveway and gives you the most protection. Now, if I were building a cage, the NASCAR style door bar is the one that I would go for. Now, as you can see here, I didn't do that design. The reason for that is because when you do that design, a lot of times you're going to have to remove the glass from inside your window. You're going to have to cut out the entire area of the door right here and basically gut it, which I didn't want to do. So I still have my stock glass in there. I still have, the entire mechanism for rolling up the windows. I potentially wanted to put speakers in the doors. So doing the idea with a NASCAR style door bar that would cut into the entire door, I was not about that. But if I was building a car which was strictly for track purposes, and I didn't mind if I didn't have glass windows and all that sort of stuff in there, then I would for sure do the NASCAR door bar design. It's going to give you the most room, right? Because it bulges out. So there's going to be the biggest distance between your hip and the roll cage itself, which is going to give you, like the most protection basically, and like a safety zone in case any of the tubes bend in or all that sort of jazz. So now we're going to talk about why I did my door bars the way I did them. So my car is basically like a half track car and half street car. So I did the double parallel design. I like this one over the X, like I already stated earlier. I did want to go with the NASCAR, but I still wanted to retain all my window mechanisms, so that wasn't going to fly. So this was basically like, to me, the only suitable design that I'd go with. So I went with one lower bar over here that goes as low as you possibly can. So I have the lowest protection that I can get on this cage. The upper bar right here goes to the halfway height of the doors, and it has a slight bend in the center of it. This bend right here is meant so it can clear the manual window mechanism, right? So I can still have the whole manual window mechanism set up in my car, because I'm still going to be using that. And I wasn't quite sure when I was building the cage whether I was going to go with an electronic setup or what, but I wanted to make sure I always had room for a manual setup in the car if need be. So this right here clears about 1 finger distance to this mechanism. So I actually have to open the door and then put on my handle, and then I can turn up and down the window, then take off the handle and close it back up. So that's how tight it actually fits to try and give myself the maximum protection. This slight bend over here also helps with getting in and out of the car, because at the end of the day, this car does get driven on the street. And I've never been a fan of cars where, the door bars go all the way up to like the full height of the door, and you basically got to like crawl in there, and it's just kind of impractical in my opinion. In addition to that, I was very careful when fabricating the front end of the door bars right here, that it would actually clear a speaker being put in. So I'm not sure if I'm actually going to be doing the speaker or not, because I've kind of gone back and forth a few times on that. But I do know that the cage will allow me to do it, because I did build the door bars with that in mind. So yeah, those are the reasons that go over my cage. I wanted to get as much side protection as I could, while still keeping it a very streetable cage and making it practical for getting in and out of, while also maintaining room for the speaker as well as the manual window mechanism. So the first bar that I made on the door bar was the lower bar right here, and this lower bar I actually made when I was doing the side hoops, because there's a little bit of room for error when you're doing your bends, for the side hoops. So I guess one of the side hoops was just like a hair off from the other side, and I want everything to be symmetrical to one another. So I made a lower door bar for the passenger side, and then I used that one on the driver's side, so that way they were both the same exact measurement. Okay, so this is the passenger side door bar. This is a really easy one to make. I don't know if it was just the angle that was measured there or what happened, but it seemed to be a little skewed, and you see how it's sitting further back on the base plate. Compared on this side, you can see how much further forward it's sitting on the base plate. I've gone and made the lower section of the door bar, which is just a straight bar that's running to the lower points of the main hoop as well as the side hoop, and they are spaced with 2 magnets stacked on top of each other on both sides. That's the increment of space. And now that I have it sitting on that side, I know that that length of door bar is also going to be the same exact length of door bar on this side. So what I'm going to do is I'm going to take that section out now. I'm going to put it on this side, and with that it's going to forcefully push the cage out to where it should be, and then after that everything should line up really good. See, so now as you can tell, I have the lower door bar in place, and you see up front how there's that big gap there. Well, what I gotta do is have someone push that side hoop down, force it into place, and then once it's forced into place, I can actually tack weld it there, tack weld the door bar in place, and then it's all gonna stay there, and that's how I'm gonna get it to fit exactly like the other side. Okay, so now I have my lower door bar in right here. It's pushed down on both sides. evenly, and it's going to match that side when it's done as well. Now that the lower bar is done, I moved on to doing the upper bar. Now, as you can see on the other side, I already have the top door bar done over there, so you can kind of see where it looks like. So I just marked up with string where the beginning and ends of the door bar are. I kind of tied it in right down here, and the bend is going to be right at where the bracket for the seat is at. That's where the center of the bend is going to be. And now with this, I can basically mock up how I want to have the door bar and get it to adjust like that. I can put more angle in over here if I pull it down, or I can put less angle. I can adjust it over here. If I want to make the bend over here, I can adjust it, make the bend over here. So basically just play around with the string, get it where you want it to. A few things to note: where to start and stop these, how high they have to be, all that sorts of stuff. The door comes up to just under 22 inches, so the halfway point would basically be 11 inches. I've made this 11 inches high on this side, and then I've made it go 11 inches high right here. Therefore, it's at the halfway point of the doors. So I got that covered, the halfway point of the doors, and you can actually make it just a straight bar that's going right across, but the reason I'm putting a 15-degree bend over here is to make it easier getting in and out of the vehicle, so that way I don't have just a straight bar to go over. It actually dips down, and that helps. On top of that, it's not really protecting too much, like right in this little area right here that you're cutting off, so it's not really a big deal to bend it in a little. But anyway, so what I'm going to do is I'm going to put a 15-degree bend in my tubing, and then come back here, readjust this, make sure it's perfect, and then I can take my final measurements using the string to see what type of notches I need and how many degrees they need to be at. Little pro tip that I got for you guys is to just use a little bit of oil. This is just, you know, random, what is this, air tool oil, and just rub it in the die right here. So that just helps eliminate a lot of the bind that happens when you're bending tubing, because it's basically just metal on metal. And on top of that, I'm going to show you something cool. When I do my bend, some of that oil is actually going to get left on the tubing, and it's going to get left on right where the die touched it, so you can actually see the entire like contact patch of your bend, and then you can mark it out, and then you'll mark out the entire area that your bend took place, so you can then take that and line it up in your car with wherever you want the center of the bend to be. I'll show you right now. Let's bend it 15 degrees. And 15. You see where the oil made contact. So you can actually mark this now right at the ends with a red paint marker, so you know exactly where your bend is at. Now it's marked out, red paint marker, super easy to see now. I got my string over here, and basically I can adjust how much angle it's supposed to have, so I just matched it to what's basically in there. And now with that, I can take my measurements, right, just like I take all my measurements with the string, and get my angles for what my notches need to be at. It was an 87-degree notch over there, and then an 81-degree notch over here. All I gotta do is just notch them to the correct length, and that's it. One notch over here. Got another one on this end. Once I got the notches right, I have my clamps underneath, which are holding it in place, because basically I took, right, my little speed square right here, held it up, and then I got my measurement to the top of this tube. So both right there, and you don't want to measure your height all the way over there. You want to measure right there, which is the opening for the door. So right at where it's intersecting the door at, that's 11 inches, and right where it's touching the side hoop right there, it's going to be 11 inches. So that's solid. So now that I've made sure that everything is good, I'm going to take these off, of course, prep it for welding, strip it to bare metal, same with over there, clean it with acetone, and then tack it in place. The next thing to do for the door bars is make two supporting beams in between the bars. FT just requires a minimum of 2, so that's what I'm going to use. So to figure out where you want to put it, you can basically just mock it up using pieces of string, kind of just like a lot of the car is done with. I just divided the length of this by 3 essentially, and I'm placing the 2 support beams right there, so that way they all have equal distance between them. It makes the most sense as well as far as distributing force to kind of have it just equally divided up. So that's the one that I'm going to go with. So just using this tool as always, kind of come over here, you get it, you mock it up, put it at the pivot point, you read the angle. It ends up coming out to 82 degrees is what I set my notch at. And then I also measured in the front, and that ended up coming out to 82 degrees as well. So they're both 82 degree notches at the top, 90 degree notches at the bottom, equidistant spacing, which ends up coming out between 15 and 5/8 inch from the side hoop to the center here, from the center here to the center there, and then from the center back. And then of course, once you know all your measurements and everything, you just go and, take a piece of tubing, you notch it up how you want it to. So you got the 90 over here, you got the 80 up top right there, and it's gonna slide in right there. Okay, now for how to measure this accurately, right? You're gonna wanna make sure you leave your 90 degree or whatever template you want on the bottom right here. Leave that template on there because it actually has a center line right there, which that marks the center of the tubing. So now when I take my tape measure, I can actually use my tape measure, and now I can read that it's just a hair over 31 1/4, and I want this to be exactly 31 1/4. So I can just tap that over. So that's basically how you figure out your spacing. Next thing to do, of course, is just to weld prep it and then weld it in place. There you go, 31 1/4, that's where I wanted it at. Bevel the edges. Now I'm going to switch over to the quick strip disc. So I got beveled edges now, taking out the bare metal, and then of course I just got to clean out the center. Now it's nice and clean. So it's just a matter of wiping this down with acetone, and then it would be ready to weld. I went and put the template back on here for the 90 degree. Is make sure you have a welding magnet on here that's going to hold it at a 90 degree angle, so that way you don't weld it in some skewed angle. It's dead on 31 1/4, so that's where I'm going to weld it now. I just got to repeat the process with the little front support. And just like that, the whole structure of the door bar is done, and it's all tacked into place and ready to get full beads welded onto it. That's it for the door bar. The next thing to do on the cage is to drop it and then weld around everything, so that's going to be in the next video. So I'm gonna cover, I'll cover this design first. Okay, so few rule of thumbs.